Okay, welcome guys. Sorry about that. Today we're going to look at solving subtraction equations. Start with this. One way to solve equation above, and I'm going to show you the equation shortly. Above, to find the number of conch shells you had in your collection at the start is to work backward. So we're talking about this equation. You know, you had X amount of conch shells, then you gave away 2, you know, and you end up with 5. How many conch shells you had at the beginning? So after giving away 2 conch shells, you have 5 conch shells. So working backward means that to find the value of X, you add before subtracting 2, you can add 2 to undo the subtraction. And this is teaching us a fundamental principle. Now, if you have a subtraction equation, you're going to use inverse operation to undo the subtraction, and that will help you find the answer. So what it means to work backward is that you're going to add 2 to your answer to find what X is. And you add 7 conch shells in your collection at the start. Just to go ahead and check that, because you have 7, you're going to put 7 where X is to substitute it. Subtract 2, you see that 5 is on both sides. Your answer is indeed correct. Now you mail 5 postcards, and now you have 9 postcards left. How many postcards did you have at the start? So you had X amount of postcards at the beginning, and you subtract 5 from it, you mail 5, you gave away, you end up with 9. So you're doing the inverse operation. You're going to add 5 to 9 in order to find out how many you add at the start. So your answer would be 14. Isolating the variables. So now we're going to use another method to solve this. You can solve the equation in example 1 by getting the variable by itself, as you did in lesson the previous lesson. Use the step below to solve it. So here we see that because it was subtraction, we're using inverse operation, and that's how we'll get 7. We add 2 to both sides and you get 7. By adding 2 to each side of the equation, you undo the subtraction while keeping the 2 sides of the equation equal to each other. So here, just look at some more subtraction equations. For these, you're going to end up, start with A. To find what n is, notice you're subtracting. We're using inverse operation. So we're adding 6 to both sides, and our answer would be 20. So 6 plus 14 equals 20. And these 6 eliminate each other. For the ones with the decimal, it's the same principle. We're trying to undo, or we're trying to find what m is to isolate it. So we're adding 3.1 to both sides. Our answer will be 15.05. You can go ahead and check your answer. It's just about estimating. We'll move on. Now you're riding an elevator. You go down 14 floors and exit onto the 23rd floor. On what floor did you enter the elevator? So here we're thinking about a number that represents the floor that you started on. You go down 4, so you're subtracting 14, go down 14 rather, so you're subtracting 14. And you exit to the 23rd floor, so that means equal to the 23rd floor. So we're going to use F to represent the floor, the number of the floor on which you enter the elevator, and then we write an equation. So F minus 14 equals 23. Once we have our equation, the rest of it should be a piece of cake. It's all about doing the inverse operation, adding to both 14 to both sides. So our answer is 37. You came out on the 37th floor. So here, inverse operation, you have q minus 7 equals 2. Use the inverse operation, add 7 to both sides. Your answer would be 9. Inverse operation again, start with the side where your variable is at, your letter is at. Add 17 to both sides, your answer is 42. It's a decimal, same principle. Add 2.1 to both sides, your answer is 5.3. In this, we're not going to do that, so that's all for today. Bye.